Good evening and welcome to League of Women Voters Presents. I'm Jim Robertson and my guest tonight is Dr. Jeff Bryan from the MU College of Veterinary Medicine. Thanks for joining us tonight,
Happy to
Jeff.
be here. Thanks.
Dr. Bryan is doing some research with dogs actually that promises to have maybe some really significant results for humans in cancers, various kinds of cancers, and we are happy to have you. Tell us a little bit about your background first before we talk about your work, please.
Great. I'm a veterinarian. I graduated from UC Davis back in 1993, and I left UC Davis with the goal of being a world-famous exotic animal surgeon, and clearly failed at that because I'm now a veterinarian doing oncology in the Midwest. But after about 9 years of practice, I realized that I really enjoyed treating patients with cancer and taking care of their families, and decided to get specialty training in oncology. And at the time, there were really not very many institutions in the country that offered residencies, fewer than 25, and one of them was University of Missouri. So I came here in 2002 and started clinical oncology training as a veterinarian in our veterinary health center over on campus. And during that process, completed a master's degree and discovered that I really enjoyed research doing the master's degree. So I stayed on a little longer, did a postdoctoral fellowship in bioinformatics and a PhD in epigenetics and radiobiology, interested in how radiation and cancer interact for therapeutic purposes, and took a job at Washington State University on faculty afterwards as a faculty oncologist there. Had an amazing opportunity to come back and contribute significantly to the program here at Missouri in 2011, and I've been back since and plan to be here for the rest of my career.
Well, good. Welcome back. Tell us about what you're doing over there.
We have a clinical oncology service in the veterinary hospital, and so we teach students who are becoming veterinarians about treating cancer patients. We teach them about cancer biology, and in the process of seeing companion animals, people's dogs and cats who are their pets, we see a lot of different types of cancer during the day. And we, as veterinary profession, noticed many years ago that many of the same cancers that we treat in our dogs and cats are the cancers that are being treated over at Ellis Fischel on campus as well. And so besides running a general clinical service where we educate the students, we also run a clinical trial service. And we have clinical trials in cancer diagnosis, cancer therapy, cancer monitoring in dogs and cats that have naturally occurring tumors. We don't cause cancer in any of these animals. They belong to families, they're beloved family members, and so people can come here to the university. They can receive essentially cutting-edge treatment, oftentimes subsidized treatment, and it allows us to learn things about treating cancer that we can then apply to the human side as well.
Is there an interdisciplinary connection with Ellis Fischel?
There really is. We teach classes with them. We share journal clubs with them. We have a lot of connection with Ellis Fischel. Absolutely.
Yeah. Yes. Well, how are cancers in canines and cancers in humans alike and different?
They're very alike in the general types that they get. What is a little bit different is the frequency with which they happen. In some cases, the frequency is much greater in dogs than in humans, which allows us to actually understand things much more rapidly in dog studies because we can accrue larger numbers of patients more quickly to apply to the more rare form in humans. In other cases, dogs get cancers very rarely that are extremely common in humans. But some of the most common tumors, like lymphoma, are fairly similarly common between dogs and people. Sometimes they're almost exactly the same disease. For example, in large, aggressive, large cell lymphomas that are B-cell lymphomas, dog and human B-cell lymphoma is fairly difficult to tell apart, even under the microscope. In more indolent forms of lymphoma, like chronic lymphocytic leukemia, they're interestingly different in ways that we don't yet understand. For example, in chronic lymphocytic leukemia, people get it of B lymphocytes, dogs get it of T lymphocytes, and we have no idea why that difference is there. And there is some crossover, but it's at the tail edges rather than in the main form in people and dogs of that disease. One of the diseases that we study a lot and we see a lot in dogs is bone cancer, osteosarcoma. In dogs, bone cancer occurs most commonly in middle-aged dogs, most commonly in large and giant breed dogs, sometimes in younger dogs, but in humans that's almost exclusively a disease of children up into the teenage years. And like with children, there is a high rate of spread of that cancer outside the primary tumor that can become life-threatening condition. And so we run a fair number of trials in dogs in osteosarcoma that are for the purpose of discovering ways to improve our treatment of children with osteosarcoma.
Mm-hmm. You, I think, brought some slides that you...
I did. And one of the trials that I'll highlight is with the Comparative Oncology Trials Consortium of the NIH. And we're very heartened right now that the National Institutes of Health and the National Cancer Institute have clearly started to recognize the similarities between dogs and humans as being a really critical step in moving the whole field forward. And a number of years ago, more than a decade now, they started the Comparative Oncology Trials Consortium as part of the Comparative Oncology program in the National Cancer Institute. And we have a map of that. It shows the United States and it shows the trials locations across the country, primarily in academic settings. And these are all locations that have more than one veterinary oncologist. They have a radiation oncologist and the ability to perform radiation therapy, and they have a clinical trial service like ours that allows them to run clinical trials. And we are currently, I believe, on the 24th clinical trial of the Comparative Oncology Trials Consortium, or we call it COTC. And these are trials that are designed to test something in dogs for rapid translation into humans. We've been involved in several at the university. We were involved in one of a drug that was discovered and introduced into human trials, and it had some suggestion that it might be a useful anti-cancer drug, but it became very quickly clear that the mechanism of action was not understood. They thought they knew how it worked, didn't pan out quickly. They took that drug out of human clinical trials, moved it into dog trials, and looked very carefully at the mechanism and identified the fact that not only was the mechanism incorrect, the actual mechanisms by which it would work probably would not scale up into a widely useful drug in people, and then they realized that they were wasting their money pursuing that drug. Yes. In another case, there were a series of 3 drugs in the same class, all of which appeared similarly useful in mice. We tested all 3 of those in dogs and identified which one was the most active. Fortunately for the patients we treated, we saw activity with all 3 of them, but one of them was pretty clearly superior as far as having better results with fewer negative side effects, and that drug has now been taken forward into trials in humans. And we currently have a trial for dogs with bone cancer that they'll receive standard treatment for their tumor, which in dogs is most typically amputation. If they have a large tumor in their arm or their leg, because they walk on 4 legs, we can remove one of them, and they tend to do very, very well. Right. And then they'll receive standard of care chemotherapy plus or minus an experimental drug following the chemotherapy. And the goal of this trial is to test whether this drug, rapamycin, will help children who have osteosarcoma by showing that it improves the outcome of dogs with osteosarcoma. The beauty is it's not an extremely expensive drug. It's a drug that could benefit dogs and people equally. It looks like we metabolize it very similarly. And so that trial we expect to finish sometime early this summer. We have already enrolled over 200 dogs in the trial across the country. So it's a very active clinical trial, and I think it's going to have a lot of power to answer that question.
And so the consortium, you interact by trading data? And
we do, yeah. They serve as a central clearinghouse for protocols, things like the tubes and things that we draw blood for the samples that will be tested later, as well as the drug itself. And then they also maintain an online data entry form, so we enter all of our data from Missouri straight into this online database that allows them to keep it all in one central location. And that is superior to paper records because we have to fill in every single blank in order to move on to the next screen, and then they have all the data captured immediately there at that end.
And the trial you're talking now is exclusively the bone.
That one is exclusively for bone cancer.
Right.
Yeah, we have a number of active trials right now, but that's our big one for bone cancer.
I see.
We also have an immunotherapy trial for bone cancer. Same concept, but instead of chemotherapy, it uses an immunotherapy technique following amputation to try to wake the dog's immune system against the tumor, and by doing so, prevent spread of the cancer using the immune system instead of using chemicals.
Yeah. Interesting. Are most of your patients from Columbia and Columbia area?
Actually, a small fraction of our patients for the clinical trials especially are from the Columbia area.
Really?
We see patients oftentimes from either side of the state, particularly the larger urban areas. So Kansas City and St. Louis account for a large caseload in the clinical trials. Down the Springfield direction and also down from the lake, people will come up for the trials. But some of our trials, for example, one of our colleagues in our group had a trial for prostate cancer using radioactive gold nanoparticles to treat prostate cancer that were made here on the Mizzou campus. And we had patients from California, New York City, Florida, all over the country came for that clinical trial.
Now, are they referred by their veterinarians? Or?
Sometimes, but with the web these days, it's amazing how resourceful people are at finding these opportunities for their animals. We have an incredibly dedicated clientele who are deeply in love with their pets, and these are family members to them, and we understand that. We treat them that way, and we make sure they get the very best care through this process.
Well, you brought some other slides, the cellular.
Yeah, I brought one other slide to show really the incredible imaging capability at the veterinary school. And you would think, if you've only had experience with taking your dog or cat in for routine vaccinations and things like that, maybe the capabilities of a veterinary hospital are not immediately apparent to the viewers. And so I brought some images from an MRI, from a CT scan, and from a PET scanner, all of which are in our veterinary hospital here on campus. We have a 64-slice CT scanner, which is exactly the same kind of a CT scanner that you would slide into over at University Hospital if you needed a CT scan there. We have a 3 Tesla MRI from Toshiba, which is one of the most advanced MRI platforms in the state, really in the country. It's an amazingly powerful magnet that allows us to do a lot of interesting research, particularly in neurology, but also in oncology, imaging even some of the metabolic processes inside of tumors using the magnet. And we will have delivered on March 24th Toshiba Celestion PET CT, which will be the newest PET scanner in the state of Missouri and actually the most advanced. Toshiba just introduced a couple of years ago this platform to the market for the human market and are interested in the research capability that we have at the veterinary school, and so have worked with us to help place one here at the university. The administration was incredibly supportive of this and helped fund this a couple of years ago, and so we're excited to take receipt of that this month. And that is a PET scan, which allows us to do when people think about looking for how far cancer is spread in the body. In humans, they think of PET scans these days, which are positron emission tomography. And we basically send a radio-labeled tracer inside the body that seeks cancer cells. In particular, they tend to be cancer cells. Some other processes will use glucose that's labeled like this, but it makes those tumor cells and tumors themselves light up on the PET scan, and we can identify very sensitively how far it's spread. And we can simultaneously marry that functional image with the anatomic CT image to see exactly where in the body that's located. And it helps us to more accurately identify where tumors have spread in patients. Yeah,
and that's cutting edge.
It really is. And this unit is optimal on this campus because we have a very active radiopharmaceutical program through the MU research reactor. So we can make a lot of different radioactive elements. We have a group of chemists that can very adeptly tag almost any chemical you would want to put into the body with those radioactive elements, and using the PET scanner, we can literally see where they go inside the body as they go. And so we expect with this scanner, with some of the new faculty hires we've had in radiochemistry in the last year that can make new PET tracers, that within the next few years will be really a world-leading location for development of these kinds of PET imaging agents that I think will revolutionize how we look at a lot of diseases, not just cancer, but heart disease and other chronic diseases, diabetes, things like that.
Yeah. Well, how important is the research reactor to the work you're doing?
The research reactor is very important to the research that we do. I have long-time collaborations with them. We had a really interesting clinical trial a number of years ago that we were one of the only institutions in the world that could have conducted the trial because we looked at dogs' tumors for the particular characteristic of a low oxygen environment. And one of the things that is unique to cancer metabolism is that they outgrow their blood supply, so tend to have pockets of very low oxygen inside the tumor. And a group recognized that that was a potentially targetable characteristic, and so they developed a clostridial organism that had its toxins removed, but it would only grow in a very low oxygen environment. So theoretically, it would home to the tumor and then grow there and kill tumor cells, as well as cause the immune system to recognize this as a bad situation and bring a lot of immune cells in to attack the tumor as well. And they were having trouble identifying which patients were most likely to respond well or which patients were not with that. And we suggested that understanding the degree of hypoxia or low oxygen would really help them identify patients ahead of time that might respond well. And so we helped them develop a radio tracer that you could put into them by IV injection, put them in a PET scanner, and you could see where that low oxygen environment was using that tracer. And that was made down at the reactor for us. And it was a pretty remarkable opportunity to pursue that. We're in the process now of developing our next study looking at low oxygen environment to help develop other approaches to trying to manage that in tumors.
So the MU has a pretty powerful infrastructure for research.
We do, absolutely.
And that's why you were excited to get the opportunity to come back. Is that part of it?
It's really true. We have researchers all over campus. I mean, I'm very fortunate to work with researchers in the medical school, in Ellis Fischel. We work with engineers to develop, new technology that allow us to deliver a lot of these. We work with the chemists in the chemistry department. We're even working in the PET project with plant biologists, looking at how, not for cancer purposes, but looking at how plants metabolize things in their environment so that we can make better recommendations to manage drought-resistant crops and things like that. So there really are remarkable opportunities with the infrastructure here at Missouri and with the minds all over campus to do some pretty incredible things. And even in the veterinary school alone, we have cancer researchers and we have physiologists that help us to optimize these approaches.
Is that multidiscipline model, is that unique to Missouri, or is that?
I don't know that it's unique to Missouri. I think that it is. I think that our ability to make it happen is unique to Missouri. I think we are one of the most collaborative campuses, and I think our administration is one of the most encouraging of collaboration that I have run across. What really is unique to Missouri is that we have all the pieces. I mean, today I walked from the veterinary school to the medical school to have a meeting with an oncologist over in the medical school. And most veterinary schools in the country are not within walking distance, even if their university has a medical school, of those other researchers. They're separated by significant distance. They're separated by other invisible walls, and it really inhibits their ability to work together. We have the reactor. We have the law school. We have the journalism school for health communications. We have the College of Engineering. I mean, we have every piece that you could want to put together that kind of a multidisciplinary team, all within a few square miles, and that, I think, is what is most unique about the University of Missouri.
I see, good. Well, let's connect the dots here. The research you're doing with canines, with pups, how will it, or could it someday be applied to humans?
Yeah.
The cure.
I'll use as an example one of our clinical trials for melanoma. Dogs also get melanoma, and a very aggressive form of melanoma. As a matter of fact, if you look historically at the literature, most dogs that develop melanoma have about an average lifespan of 8 months after diagnosis. Very aggressive. We probably do a little better than that these days because veterinarians are more aware to look for it. Their melanoma doesn't happen on their skin, it happens in their mouth, which is really interesting. They do get skin melanomas occasionally, but not nearly so often. So theirs is not from the bad habit of laying on the beach without your sunblock, theirs is for another reason. However, there's a lot of evidence that both the immune system's interaction with the melanoma as well as the underlying genetic mutations have a lot of similarities. And so that, along with the biological behavior of being a very widely metastatic disease where it spreads all over the body, we think it's a really interesting model. And I've been working with a researcher here who's actually in women's and children's, who had this concept that we could modulate how the immune system interacts with the melanoma by taking the dog's own tumor cells and creating a vaccine that we specifically modify before we put it back in the dog's body. And so we started a clinical trial where we do that. We'll do surgery, remove the tumor, make a vaccine from the tumor cells, and then treat the dog with that vaccine 4 times. And we've had some really remarkable results so far. We've had one dog that actually developed spread of cancer to its lungs, which is typically something that happens in the last few weeks or months of a dog's life. And after the last vaccination, those metastases disappeared on the radiographs, and that dog lived almost 2 years without any recurrence. And actually, sadly, we lost him in the last couple of months, but as a very, very old man. He was 16 years old when he passed. We've had another dog that we originally found from a metastatic lesion in a lymph node. We couldn't find where it started, but we could find a large tumor in a lymph node that had spread to. And that dog is now over a year out, had one other small recurrence in the arm, made a second vaccine, and she remains disease-free. Within a lymph node, she should not have lived more than 4 or 5 months by the typical rules of melanoma. A patient with anal gland cancer that had a vaccine made had its tumor removed, but the biopsy showed clearly we hadn't gotten the whole thing. There was tumor left in the body where it was removed, and that dog's over a year out with no recurrence. So this is homegrown technology. We had a researcher on campus with an interesting idea from the medical school. He's a PhD researcher. He's not an MD. And he talked to MDs. They suggested he talk to the veterinary school. We talked to him. We thought this sounded like an interesting concept, and here we are with a what appears to potentially in early days be a very effective treatment option. And the amazing thing is this treatment option has shown no negative side effects in these patients at all. I mean, beyond we give the injection like you would get a TB test, just the little bleb in your skin. That's the most discomfort they have. They don't get sick. They don't have pain after that. And we've seen some pretty remarkable results, and we're very, very excited about that.
Yeah. And how might that then be work its way up to trials with humans?
The technology is entirely transferable. We could do exactly the same thing with a human tumor, and in fact, that's exactly what our plan is. As soon as we have a little more mature data so that we can convince safety folks that it would be a reasonable thing to take a person's tumor and make a vaccine out of it and put it back in their body and trust that that would have some effect, that is exactly what we plan to do. And it would, we would want to have it in a proper manufacturing environment, that we know that the quality assurance is there, that we can document beginning to end the chain of controlling that tumor so that we can make sure that it's the best possible vaccine. But it's all facilities we have here on campus at Missouri.
Well, the research is exciting. Would there be a way to then take that technique to market?
Yes, absolutely.
And is that
we plan to do that. And actually, in full disclosure, Dr. Clark and I have started a startup company so that we can start to lay the groundwork to make that happen exactly, because we want to see this happen. The beauty of this technology is there is no reason that this needs to be an expensive technology. I mean, for literally a few $100s of materials, you could do this for people. So this does not have to be a multi-million-dollar drug that is put out there. This is a potentially effective therapy that can be very, very affordable, and that's exactly the kind of advancement we need. We've worked with other groups that have developed drugs themselves. We have a collaboration with the University of Kansas. We have a collaboration in immunotherapy with a company called Elias Animal Health in Kansas City. They have a human arm. They are already starting clinical trials on the human side, and they are introducing this into the pet health market space, but also doing research that they support and fund so that we can best understand how it works, how it's applied, and learn lessons that will make the human trials more efficient and more effective.
Well, that's really pretty exciting.
Yeah, well, I'm thrilled. It makes it easy to go to work every day, for sure.
Yeah, no doubt.
It's an exciting thing, absolutely.
Well, what else are you doing over there we need to know about?
Well, I guess one thing I'd like to say, because I hope people will see this, is the kinds of things we're looking for in clinical trials. We have clinical trials for melanoma. We have clinical trials for anal sac cancer that I mentioned, and that's something dogs get that people don't, and so that's an important one on the dog side. We have trials for osteosarcoma. We have some new trials for really any tumor on the surface of an animal, including oral squamous cell carcinoma in cats. And that's another interesting disease that's really a lot like head and neck cancer in people. The same kinds of tumors we get from chewing tobacco, cats get from their lifestyle, and we have some vague ideas of what the risk factors are, including things like canned foods, but it's not clear entirely what causes that. And one of my graduate students actually has a side project looking at that as well. And we have an imaging study looking at soft tissue sarcomas. Sarcomas are another disease in people that are very, very frustrating to treat. mostly because they're insidious and they kind of spread before you notice them within the tissue, and they don't happen nearly as often in people as they do in dogs, and so it's very difficult to do clinical trials to understand how best to treat them. So we have a PET imaging clinical trial of soft tissue sarcomas in dogs, and the whole purpose of this trial is to generate an understanding of what we can and what we can't learn from a PET scan in a dog, so that we can narrow our hypothesis for a trial in humans, so that hopefully we can get a lot more information out of a small number of patients. Whereas if you had to start from scratch in people, you could easily head in the wrong direction and waste your time and not get out of those cases what would be interesting to know.
So, and you're always looking for new patients?
Always looking for new patients, and we are always happy to help any family whose animal has cancer, and we even take care of horses now and then who come in through the equine service, and we go down and consult. But the patients that come into our trials often present to us through the clinic first, and we discuss what the options are, both standard of care and also these new experimental options, and people are given all their choices.
So if your pet needs attention, just contact the
veterinary health center. Our phone number is 573-882-7821, and you can look it up on the web. The cvm.missouri.edu has a link to our veterinary health center, and we've got a lot of information there that's helpful to people who are going to come for an appointment. One of the neat things about coming to our hospital is you're going to meet a veterinarian in training, you're going to meet specialists in training, and you're generally going to meet a faculty member too, and so you get a lot of minds looking at your animal.
Great.
Yeah.
Well, it's been fascinating and nice to meet you.
Very nice to meet you.
And thanks for coming, Dr. Jeffrey Bryan.
Happy to be here.
Hope that you've learned something tonight that you can tell your neighbors about, and keep your pets healthy and safe, and if they're not, bring them to Dr. Bryan. So until next time, I'm going to tell you good night.